time division multiplexing. What is multiplexing?
Passing one or more signals.
Number of inputs, single
Transmitting one or more signals through a single channel.
Perfect. In communication, the most scarce things are two things. One is channel. Channel is very limited. And the next one is bandwidth. Keep remember. Everybody want bandwidth. Everybody want channel. Channel, it may be a coaxial cable or free space air. If it is wireless communication, air is the only channel we have. So now if I want to transmit more than one signal into the air, in AM and FM, because we have a bandwidth from 540 kHz to 1650 kHz, or in FM 88 MHz to 108 MHz, 90.4 MHz will take a bandwidth of 200 kHz. 90.4 MHz will take 200 kHz. 93.5 will take 93.5 MHz channel will take another 200 kHz, so on and so forth. At a time they can transmit. Now, out of 88 to 108, what is the total bandwidth we have? (88 to 108) total bandwidth of FM. What is this entire band range? How much? 88 minus 108.
20 megahertz.
So 20 megahertz is allocated for FM radio broadcasting by Government of India. And I am saying that each channel will take 20 kilohertz bandwidth. If that is the case, you tell me between 88 to 108, how many number of channels can be transmitted at a time? Each channel 20 kilohertz. Total available spectrum is 20 megahertz. I want the number of channels. How much? You can use pen and paper, of course, your mind also. One radio station requires 200 kilohertz. I said a total bandwidth of 20 megahertz, that is from 88 to 108. How many number of radio stations can be set up within the band of 88 to 108? If each requires 200, then 20 megahertz, 20 mega divided by 200 kilo is 100 radio stations can be accommodated between 88 megahertz to 108 megahertz. That means from, say, this is 88 megahertz and this is 108 megahertz. So this is my first channel, second, third, fourth, fifth, so on up to 100th channel. Now, what is the x-axis here? X-axis.
Channels.
No, channels are the numbers I made. I am asking what is this 88, 108? What is this?
Frequency.
Frequency. So, because 88 to 108 is allocated for FM radio, commercial FM radio broadcasting, and we know that each radio station occupies 200 kilohertz, and we divided the available spectrum from 88 to 108. So the frequency is divided, and this type of thing is called frequency division multiplexing, because somewhere here I got 90.4 megahertz, somewhere here I got 93.5 megahertz. Now in your radio receiver on your mobile, you tune to 90.4, you can listen to 90.4 megahertz. Immediately after 10 seconds, you tune to 93.5 megahertz, you can listen 93.5 megahertz. That means your radio receiver receives all the signals all the time. This point is very important. But the frequency is limited for each channel. Such type of multiplexing, all these radio channels are transmitted into the air, but each channel is identified, or each channel is subdivided with their respective frequencies. Such type of multiplexing into the channel, all signals are transmitted at a time. So such type of multiplexing is what we call it as frequency division multiplexing. Can anyone tell me what is the disadvantage of frequency division multiplexing?
Sir.
What is the disadvantage of frequency division multiplexing?
Bandwidth is more, sir.
Bandwidth is not more, bandwidth is less. I'll tell. See, the advantage here is all the time we can transmit all the signals. That is the biggest advantage of frequency division multiplexing. But the problem is, I said, okay, one channel occupies 200 kilohertz. Assume instead of FM, if I go for cellular mobile, my required channel bandwidth is more. Instead of 200 kilohertz, assume 2000 kilohertz each channel requires. Then these 100 channels will now drop down to 10 channels. That means bandwidth is limited, but we can transmit all the time. If channel bandwidth increases, number of channels decreases. Try to understand. If channel bandwidth increases, number of channels decreases. That is the disadvantage of frequency division multiplexing. Now, what is time division multiplexing? Time division multiplexing is very simple. I have user 1 here, user 2 here, user 3 here. And now I want to transmit the signal from user 1 to the channel, user 2 to the channel, user 3 to the channel. What I do is I spend, say, 10 seconds at user 1, and I remove from user 1, the switch is moved to user 2. Here I spend 10 seconds. So user 2 information will be transmitted on the same channel. I spend another 10 seconds here. User 3 will be transmitted on the same channel. Again, the switch rotated to user 1. Now the advantage here is during this 10 seconds, whatever the bandwidth you want to transmit, you transmit to the channel. It is 200 kilohertz or 2 megahertz or 20 megahertz, whatever. Here bandwidth is not limited. So full bandwidth, infinite bandwidth you can transmit on the channel. After your turn, the switch moves to the second user. He also can transmit all the frequency, infinite bandwidth frequency. Then the switch is moved to user 3. He can transmit all the frequency. The advantage here is you can transmit infinite bandwidth. Can anyone tell me what is the disadvantage here? 10 seconds, 10 seconds, 10 seconds, I said. So time is divided across all the users. Again, it is rotated. What is the disadvantage here? Disadvantage of TDM. Assume my number of users instead of 3 if I have 1000. 1000 users are there. Then from user 1, user 2, user 3 up to user 1000, the switch moves. As a result, the user 1 has to wait, or delay comes into picture. Even though you can transmit all the frequency, time is limited. Time is limited. That is the disadvantage of TDM.